So, God bless you all with His honor and peace in your soul. So, are we there yet? No! What I am working on? Heavy metal. Yes, we can look at that. Paper! For example, what else? Wait. Okay. We have got we have got that. Wait, I turn the camera. I try to position it. Position. Wait, because I have to charge it. I have to charge it. I must charge the phone. So we disconnect the klima apparatus. Homeless is working. Yeah. And we have here some cables for the oscillograph. So it's very hot here. Sorry for being without any cover on my chest. It's not so bad. So, just a moment, sorry. I am now preparing the work. So here I have got the measurement probes for the oscillograph. And what we will do today is, so if the Lord Jesus allows me, please protect us, give us peace. So the plan is to take that ferrite core, it was a center tapped. I have desoldered, separated the center tap point, and I wish to drive it by as 1 to 1. So here the winding and here the winding, input output, step up and step down config. But wait, because the trick comes now. Sorry, I just positioned the cam so you can see me and the concept going on. So like, oh yeah, you don't have to see me, but you should see the work at least. Just a moment. So homeless is working under of a bridge in zombie apocalypse. The point is we have high side switching. Coil, and if you take that silicium carbide MOSFET, this is a silicon carbide, silicium carbide, it's a very good stuff. It's a high power and really fast switching MOSFET for high voltage, about 1200 volts and 30 amps maybe. Yeah, this is an isolated gate drive system. It's an industrial gate driver with galvanically isolated input and outputs. So it's a special one, not like a normal IR 2110, for example. That that is boost trap config. Boost trap I cannot trust. But here we have a galvanically isolated small ferrite ring system for the power supply of the gate driver chip. Okay, so it's all galvanically isolated, and the input voltage is also stabilized, so I can give from 12 volts up to 50-60 volts an input. So for the MOSFET driver chip, and input side and the output side is all galvanically isolated and stabilized. Pull down and pull up resistors are different, so the switching off time is shorter and the turning on time is a little bit softer. That's a normal config. You can set by this isolated gate driver, you can set the gate source charging up, the rising time and the discharging time. Yeah, so otherwise it was a special configuration. I just will rebuild it and modify, but as you can see, that small transformator was not a joke there. It was between this condenser, which is on the negative side, and a coil system. It was a series LC config, and I have tried to set up a 0 volt checking transformator for switching automatically self-oscillating the series LC. But I have used the wrong outputs of that small transformator. This brown cable comes in between the condenser and the coil. Like that, we are able to measure the sinus, the current in between the condenser, the series LC. It's so funny. You can set it up like a 0 volt switching circuit in high and low side mode. That is very interesting. A series LC, high and low side driven, can be a self-sustaining system. But now we just make a 1-to-1 input output, 1-to-1, but high side driven. So when you pulse that stuff, that coil, here is the MOSFET. MOSFET will be not on the negative side, but on the positive side. That is called high side switched. You pulse that coil and the back EMF comes back immediately after that pulse directly into the power supply. So if you set the resonance frequency of that ferrite ring, for example, if you are brave enough and you are lucky, you can find the resonance frequency of that core. That is called ferroresonance. The core's inner impedance, the flux density, and the coil's self-capacitance and inductance, it's all dependent, all working together. So there are many times so-called sweet points in the frequency. You have to choose the right frequency, seeking for it. So back again, high side driven. MOSFET comes here on the one side, for example the yellow, high side driven. We pulse that coil and the back EMF comes back immediately into the power supply. And now on the output you have a settable voltage, and again if you set the resonance frequency you can achieve a really good power point, a really efficient power point. So this is the main point. Woo! How to set the cam. There should be more modus for wide angle and like that, but how to find it? If somebody knows, please. How to make a change? Oh. How to set it up? I don't know. So this is the normal YouTube program. It's not the Camera Feel Live. It's not an external program for streaming. Those are better otherwise. But the streaming quality with the original YouTube I find much better. Peace. So, what I should try, it is a ZVS, the galvanic isolated gate drivers power supply is a ZVS configuration. I have normal ZVS transformation and a coil system which comes in between the two separated ferrite cores. So we drive through the energy, we connect that, we bridge the energy and try to matching the impedance of the transferred energy by the method of the transferred energy. In that case I have a coil and a capacitor in series with another coil. So the degree ones, they are just a few turns, and in between comes a condenser. That's how I set it, that, and it works. So the energy is very well transferred, but the driver stage is not MOSFET. I want to change because these are really inefficient. The cheap ones, not even the original 13007 bipolar transistors, and for ZVS that is really not so efficient. I wish to change them now for simple MOSFETs for low voltage, low amperage. Anything you find just must be quick enough, fast switching. So instead of bipolars, which I have now, I wish to change them now for MOSFET. So that will be galvanically isolated power supply for MOSFET drive. High side driven stuff, that is very important. So I make a diagram now for you, so for people who connecting now to this live stream, to be able easier just directly see how the diagram looks like, connections, what kind of MOSFET, gate driver system, how is the galvanically isolated power supply made. Because by high switch you need either galvanically isolated power supply or bootstrap config. I find bootstrap a nightmare. It's unstable and I just don't like. So now I use industrial MOSFET driver. More correct. So let's see. Yeah, I can show it to you. Why not? This is another project where I have some new paper. Ah, there it is. It's not new, but erased the previous diagram. I have just erased, and that's, yeah, that's nice. So, I hope you can see. Huh? Okay. So, it means we have input power. Let's say it is an XT60. XT60, that yellow stuff, you know, for scooters, whatever. You know that. It's a very well known and good quality connection. So input from 12 volts in, from 12 volts to 60 volts, about, around. So there we have plus and minus. I hope you can see something. I will show to you in with the other cam. Maybe I could turn it to use the front cam, but then I don't see the display, so wait, a charger cable like here. So just a moment, because the live stream is eating the battery. Okay, it's connected. We have positive input, put, negative input, and what we can do, we take emitter follower circuit. I bring the camera a little bit more near so you can see it better. So sorry for being acid. Wait, how to show it? Can you see? Because I cannot see the monitor display of the phone. A little bit more higher. Like that. So the sweet point, the sweet spot. The sweet spot. The sweet spot. Yeah. Okay. My underwear. So yeah, this is input. We take an emitter follower, so-called emitter follower. Let's say this is an NPN transistor, and that will stabilize for us what? The input voltage for the gate drive. Like we have a Zener diode, it goes to ground, which is here. Wait a moment. You must see it really good. That means for us we take a resistor from the incoming positive, we take that power, we pre-open the base of the NPN, and on the same point on the base there is the Zener diode, 20 volts or 15 volts, whatever your MOSFET can handle, or driver IC input. because the MOSFET will get another galvanically isolated voltage and power. So NPN, for example, BD 241, and that can handle 3 amps and 100 volts. So here the negative from the power supply coming in, positive, negative. Can you see it? I hope. You have on the base of the transistor the Zener diode's cathode. That's the positive of the Zener diode. The anode comes to the negative of the power supply, okay? That's the negative, that's the positive. So the reference voltage you give on at the negative, like that. You pre-open with, for example, 1 kilo ohm, that base, and you give a few milliamps, 10 or 20 milliamps for the Zener diode. Like that, you have a reference voltage on the base, which is not closed yet, because you need a load to be able circulating that current in the emitter follower voltage stabilization section. So here comes the stabilized output. We can write stab 20 volts, the positive. That's why it is called emitter follower. Okay? Okay. Good, Bambini. Very good. So next step. We can begin with the MOSFET driver. I think, for example, here. Its model number, it's a special industrial one. I will write it later in the description under of the video. So this is the input, the signal, the driver signal, and this is the driver of the MOSFET section. Let's say negative, or here the positive, here the negative. This is now the galvanically isolated power supply, which will come later, direct for the MOSFET, okay? And the outputs, the sinking and the source. So sink, or wait, here comes the source of power, so the charging power of the driver stage. The gate source charging power, it is called source, so that is not the source of the MOSFET, okay? And the sink, like sinking, sucking out the gate source charge, the capacitance charge. For charging up, we can write also charge. Gate charge, and sink is gate discharge. Can you see? I hope you can read it. And happy end. Two different values. Why not? Because that is the correct config. For example, for charging up, you have 10 ohms or whatever, from 7 to 10 ohms. For discharge, you have a lower value, like that you can really quickly discharge that gate source capacitance. that is, for example, 3 or 5 ohm. Okay?
Okay.
Nazi. MOSFET. And now comes the trick, because this is high side driven. So we take the positive power supply. Can you see? Positive, okay? Can I make some color if you wish?
Yeah, please.
Ok, bambini. Tutto bene. Così. Positive. Così. Negative. So, we take that positive input, the direct input, where the MOSFET comes. There is draining the power to the MOSFET.
Yoo-hoo!
Positive input. High side driven means following. This is the drain. This is the source. This is the gate, of course. It's already driven by our beloved galvanically isolated MOSFET driver, industrial one.
Yoo-hoo!
So we take the source, we bring that ferrite ring, once output coil 1 to 1, input coil. Okay, we connect that to the higher side of the input coil and the lower side of the input coil, where it comes
To the ground.
yeah, bambini, to the ground. Brave, very brave. So here it comes, the negative.
Why?
Here.
Okay.
So negative. Just make it again. Make the word great again, like the Tartarian. So we take the negative, like earth grant. I try to not cross everything with each other, but yeah, it's just like that. So carefully. There is it. You can earth grounding it. Why not? Maybe you can get some earth pump effect. So input. The driven coil is high side driven. It means that the MOSFET is not on the ground. Normally first comes the positive on the upper end of the coil, yeah, positive input, then coil, the other end of the coil, and the MOSFET drain, and the source comes at the negative, yeah, normally input negative. Now it is opposite. Why? Again, input power supply, for example 58 volts battery pack, or solar panel 42 volts. You take that input power to the MOSFET's drain, and the source comes at the input of the transformer, so the primary coil, and the other ending of the coil, the primary coil, comes to the ground. The driver stage, we will discuss it later. You must find the sweet point of the resonance frequency. You have to seek for ferroresonance where the input current is really low, but the impulsed radiant power will be a little bit higher. First of all, as you seek for resonance, you will find a point where it is consuming less and very efficient. But when you are lucky enough and brave, then you can find an extra point. Really fine-tune it. It depends on just a few kilohertz different. Just a few kilohertz different. You can find another sweet point of the system where the ferrite core begins to live. It has an other sounding, and it is working more softly and consuming really much less compared to a normal random input frequency, driver frequency. So seek for ferroresonance, for the sweet point. Yeah. The output you can collect into full bridge rectifier system, and there are many methods to achieve even more, a lot higher efficiency, but that will be basically the output. So you can make a DC step up, step down with the same circuit, and really efficient. The main point is, as you know, when you drive a coil, you take a pulse wide or a pulse. After powering the coil, you cut the energy. What is happening?
What is happening?
That happens, occurs so-called back EMF, an transfer of the ether from the surrounding energy of planet Earth. So you bring it in resonance, the coil begins to suck the energy from the environment. If you are working on the true resonance of the system. But anyway, there is always a back EMF that is a really strong high voltage spike. That energy can be a lot. You drive that energy, and here comes the point. Look at that.
Why?
Here.
Okay, where? There?
Yeah, they are here.
Okay.
What is that?
What is that?
The body diode. Oh, where is it? I don't see. Sorry. The body diode of the MOSFET.
And what is done?
The body diode conducts the energy. The back EMF
Conducts where? To where?
into the power supply back.
Yoo-hoo! Okay.
Understood?
Yeah. Okay.
So of course we need some capacitor bank. Why not? Because we are brave enough. Can you see?
Yeah.
Okay. Plus, minus. Electrolytic capacitors. And what else?
What?
For example, 10 millifarad. What is milli? 1000 times micro. So we don't say 10,000 microfarad, but we can say 10 millifarad. Okay, learn please. Yeah, sorry. Then we take 1 millifarad. What is that?
1000 microfarad.
Yes, bravo. Bravi ragazzi. Then what else? We can take some Vima folia condensers.
Yoo-hoo! Yes, we can.
Okay, that's enough, Bambini. So, for example,
What?
Vima 1 micro, Vima, or whatever, 2.2 micro, Vima. And here you can take 100 nano ceramic, whatever. So they must be mixed in every type and every size because of the impulse-like system. The more than 1000 volt back EMF, you must be able to handle that power. So this is on the power supply, positive and negative input. You shoot back directly that back EMF into the input power, okay? Battery source, whatever. Be careful, if you don't take that capacitor bank, that condenser bank, you kill your battery. And the driver stage will be also unstable. Yeah, the usually driver signal from TL494, TL, 494. You can set that time, you can set the frequency and fine tune. You can give voltage stabilization, so a feedback from the output. Okay, from the output you can sampling the voltage and stabilizing. So this is really important. And with the dead time control, you can even produce impulse signals. That means 0.5 to 1% of duty cycle. That is an impulse. And then it will come the really interesting effect. I have tried it already, but did not improve that system. Only just tried for a few hours. Was experimenting with it. 1% of duty cycle impulse like had the same effect as about 15 or whatever, about 15-20% of duty cycle. The same output voltage on the secondary I have measured, and that was really fucking interesting. That was a parallel LC config, and not even high side driven, just a normal mode. It was so interesting. I have set the TL494 on the dead time control pin. That is the fourth pin. Otherwise, you give a small voltage from 0.7 to 3.7 or 4 volts. I mean, this is the and you can set the dead time from 0.5, 1% to 97. I mean, I have set it about 1% of impulse wide, and it was really interesting. I have seen this method from other Tesla researchers, and yeah, I can tell you that is a really good way to experimenting. So the main stuff now I wish to make, first of all, in the simplest version, the high side driven galvanically isolated 1-to-1 ratio wounded transformator. And this is it, because I have a solar panel system and I wish to have a really good, efficient DC step up, step down transformation with current limit, because now I only use some halogen lamps to limit the current of the solar panels. I have two pieces of solar panels, each 350 watts, I guess. The glasses are broken, but they still work. Bless it, Lord. So, give for all who need it, who are in need, peace and your love and protection, Lord. So, this is the basic concept. Now maybe evening time better to work. Why? Because that is now 26 degrees of Celsius in shadow. So it's really nice weather. Thanks, Lord. And the soldering iron would kill me now with its heat, of course. So if not the zombies, then the soldering iron. So I think this is the beginning of a beautiful friendship. Did you see the Black Cat, White Cat? That Bulgarian, Romanian comedy. This is a gypsy comedy. A really known, very famous comedy. Louis, I think this is the beginning of a beautiful friendship and adventure. So, okay, God bless you all. Later in evening time, please pray for me, for the protect of the Lord. It's not easy. I have to build it, modified it already halfway, 70% finished circuit, and so checking for stabilized input voltage, stabilized output and gate drive, little bit modifying, bring it connected together with my TL494 circuit, which is somewhere here.
What is it? Please show us.
Is he?
Toto.
For example, that. This is it. Frequency control, dead time control. What the fuck is that? I mean, this is the current limit, and this is the voltage control that comes at the output voltage. This is the feedback for voltage stabilizing on the output. This is the so-called emitter follower.
What?
Here, this
Now I see.
this NPN transistor, pre-opening resistor between the base and the collector. Zener diode
Why I cannot see.
is here. Patient. There it is, Zener diode, coming with anode to the negative
Okay.
and cathode to the base, which is pre-opened with that resistor connected to the collector. Collector is the input positive.
Okay.
Output is the emitter, the voltage on stabilized value.
Okay.
So this is it. Now I take that. Some fucking zombies. Zombies! Protect us, Lord! Taking photos. Okay, each photo 100 euro, thank you, motherfuckers. You know, thousands of people are coming here nearby. thousands of tourists, cycles, families, no idea of fucking shit, godless people. Why I say fucking shit, godless people? Nobody cares, you can die on the street. That is the best in winter time, during winter when it is minus 20 degrees of Celsius. That was funny. So, okay, now I show you this circuit.
Okay, show us the secret. You fucking homeless. Just die on the street. Who the fuck cares?
Okay, this is it.
You.
So, inputs coming from the TL, of course. Drivers, here comes the galvanic. Ooh, it's beautiful. I am right-handed, not left. Galvanic ISO PSU power supply unit. Units are it. This is like in unit the power.
Okay.
It is all here inside in this box. So if you are inside of the box, just free yourself and get outside of the box. So this is now out of the box, that system, okay? Here is a galvanic isolated gate driver power supply, okay? This. I have already talking about an hour long. So thanks for your prayer. It's connected here to the power of the driver side. Now I can show you the MOSFET driver. Oh, maybe can we see the number? Yeah, we can see it. It's 1I 50M12A. Come on, fucker. This is again 1I, like isolated or infinon, 50 and 12A. That is the MOSFET driver, okay?
Okay.
No, so I cannot loop back. Yeah, now I can. I wish you all the best, honor and peace, because not all the best is the real best thing in your life. Think about it. Fucking zombies. What the hell? He is the 500th man today. Then they will look, but could not see nothing. They will hear you, but could never understand. Because they are fucking zombies! Zombie! Zombie! Save us, Lord.